Hi everyone, thanks for joining us today. Padang and AstroHub are very excited this year to provide you with a really interesting set of challenges for the NASA International Space Apps Challenge. The part of this year's program that I find most interesting is we are actually going to have access to data not just from NASA, but from other countries as well, the Japanese Space Agency, the Canadian Space Agency, among others. So what I'd like to do now is give you a brief overview of why I think you should be interested in space, and then talk a little bit about the challenges themselves and give you a sense of how the data are structured and potential problems you might think about. And then finally, I'm going to have a call to action to think about your future in the global space sector. One of the things that we like to do in partnership with Padang is give you guys a sense of how the data sets actually work. We know that there's a lot of information that's going to be presented to you in a very short period of time, so let's just go ahead and get started here. This is actually one of my favorite pictures from outer space, and I wanted to show this to you because this really gives a sense of how outer space is now accessible to your average person. What you see here is the International Space Station with its robot arm in the foreground, and the rainbow you see is actually the Earth's atmosphere. This is an image that was taken from the space station, and the streak in the lower left is the SpaceX Dragon capsule flying back to Earth from the space station, and on board is a set of experiments from a school in Singapore. So very quickly, let me just tell you about myself. I've been in the business for more than 30 years, and I worked for NASA and I've worked in the commercial space sector. And my goal right now with AstroHub is to provide space-related training and education. So space tech is already a part of your life, right? You use your phones on a daily basis. The GPS on your phone constantly talks with space satellites so that you understand where you are for all the different apps that you run. Space provides a unique vantage point observing large swaths of the Earth. And in outer space, there are abundant resources. For instance, you could mine without environmental impact to the Earth itself. So all of the minerals that we extract from the Earth here also exist in outer space on asteroids. Microgravity, that is an area without the tug of gravity, is very important in terms of pharmaceutical development and manufacturing opportunities. And there are a number of companies looking at this already. And most importantly, in the post-COVID global economy, we're going to need a lot of solutions to unique problems that we recently discovered. And satellite-based imagery can provide large-scale data for food security, supply chains, and a number of other areas. So to really think about this, what sectors are currently active? We're focusing today on Earth observation, but if you're interested in satellite manufacturing, communications, space exploration, etc., commercial space stations, medical research and manufacturing, all of these are real. All of these are areas where companies globally are working at this moment. So space technology can provide solutions to global catastrophes. We see here an image of the Earth of crops for food security, and we also know about natural disasters that you can monitor from space. You can even look at construction sites, and you know that space-based internet will soon be able to provide signal to very remote parts of the world. So let's stop for a second and think about natural disasters. In Indonesia, we have a serious problem with fires that affect Singapore significantly. It would be wonderful if we could actually provide Indonesia with affordable satellites that can allow them to look where they want, when they want, and to catch fires as they first begin, rather than waiting for a day or two when it really is too late and the fire has spread. Another interesting area is in New Zealand. There have been issues with encroachment on native Aboriginal lands, and the indigenous people have actually been able to use satellite data to identify areas where their land was being illegally built upon, and they've taken these cases to court, and by doing that, they've been able to get their land that's rightfully theirs and keep the construction companies away from development. And finally, in terms of the new space ecosystem, we talked about food security. I think farms are a really interesting area where we can look at satellite data for a number of different things, everything from crop health to managing crop readiness. On to the NASA Space Apps Challenge. This is a hackathon with NASA curated data, and this year for the first time we have data from other space agencies as well. The main goal here is workforce development. Since 2014, there have been a number of important outcomes for people who participate in this challenge, such as yourself. The winning team from 2014 is now a 22-person space startup. They look at satellite data. 2016's winners have jobs with NASA. And here in Singapore, we ran the challenge Padang and Astro Hub in 2017 for the first time. And one of the teams from Singapore representing the country was a global winning team. There were 25,000 participants worldwide. And just think about the kind of talent that we have here in country. The fact that people are actually able to go out for the first time and compete globally and win for Singapore. My primary goal today is to give you a sense of how the data structures work and how the challenge itself works. So for 2020, the theme is Take Action. And what NASA does every year is they provide different categories. You see category 1 and category 2 here. And then underneath each of the categories, they provide challenges. So in this case, you see challenge 1A, you see challenge 1B and C, and then challenges 2A and B under this category number 2. And if you delve one level deeper, you'll actually be able to get some data sets. So this is where you get the really interesting stuff. You're getting access to data that's been put together in a very meaningful way. This is the kind of thing that scientists do all the time, but scientists typically don't have something handed to them this easily. They have to go in themselves and poke around through a rather large amount of data. And this is part of the reason that they want you to run the challenge. NASA would like to get an idea of how to be able to manage this data in an intuitive way rather than having some team of scientists go through just many directory trees trying to find what they might need. So in terms of the categories for 2020, we have 6 categories plus invent your own. So you can look at observing, informing, sustaining, creating, confronting, connecting, or inventing your own challenge. We're talking about taking action, so let's look a little bit more at what this actually means. I'm going to use as an example category number 2. For category number 2, we have data available from NASA, from the Canadian Space Agency, CSA, as well as the Japanese Space Agency, JAXA. So if you want to take action and inform, what you want to do is identify processes for engaging stakeholders, including the public, using space agency data to promote scientific and historical knowledge. That's the basic problem statement. The things that you can really look at in detail there are: what is our carbon footprint? Automatic detection of hazards. Mission to Planet Earth, a digital history. The MOPIT instrument will provide a bunch of public data, and let me just go through now and show you what that looks like. When you go to the NASA International Space Apps Challenge page, you will find a section on automatic detection of hazards. If you click on the details, you get some information on the challenge. And if you click on the resources on the right, you can see there are example resources. The Japanese Space Agency and the Canadian Space Agency also have resources. So if you click on the CSA resources, you get a bunch of instruments that you can select from, including MOPIT. MOPIT actually measures carbon monoxide, which is an immediate product of forest fires. MOPIT data is used regularly with surface observations to look at concentrations of this toxic gas. And as you may already know about carbon monoxide, it is a toxic gas produced from incomplete combustion of auto fuel or biomass. That's the forest fires. Any of the data sets that you go into will provide a brief description of what is actually being measured, and you can go in and research yourself further if you're not quite clear on what they actually are measuring and why it's important. On the Canadian Space Agency page for MOPIT, which is on the Terra spacecraft, they discuss a little bit about the satellite itself, And then at the very bottom there on the left-hand side, you see an offering of resources. There is a data subset from March and April of 2019 and 2020, which I'm going to go through with you in a second. But on the right, what you can see is a map of carbon monoxide mixing ratios, parts per billion. And as you might expect, the northern hemisphere of the Earth is more heavily impacted by carbon monoxide, and you can see particularly in Asia and Eastern Asia that there is a significant impact from large amounts of carbon monoxide. So we've clicked on data subset for March and April of 2019 and 20, and then you get immediately brought over to this file site, this FTP site. On the Canadian Space Agency page, there's a little bit more information about MOPIT, and they give you a couple different areas you can go to look for data. There is a data subset from March and April of 2019 and 2020, and if you go and click on the Space App COVID-19, now they're going to have the same directory again, something similar for the Space App Challenge for this year. You go in and you look at that, and this is just to give you a general idea of how the process works. You can see, you click on that, you get the 2020 data set, and there's also a Python script in there you can use to convert the data. And then you get a bunch of these files. In this case, they happen to provide you not with images, but with raw spreadsheets. And the spreadsheets look something like this. You get latitude and longitude, and you can look at mixing ratios, column densities. All of this is explained on the websites. So then one thing you might want to do is create some kind of an automatic tool that goes through and based on lat and long does take this data and put it into a 2 or a 3-dimensional visualization so that you can automatically grab this data from the server as it comes in and be monitoring the carbon monoxide levels on a global scale. Now that we've looked at how the data structures work for the challenge, let's think a little bit about you and your potential role in space. As we said earlier, there are many different areas where you can be involved in the space sector. The space sector is going to be a $3 trillion economy by the year 2040. Think about that. We're now moving from a proof of technology sector to consumer products and services. And my big question to you is, where's the workforce? The workforce is actually going to be you guys. You will be needed in sectors from business and marketing and media, legal and finance. And what we actually do is we provide training and education to allow you to become important contributors in these areas. You can look at all these kinds of things like sector growth, consumer buy-in, property rights, or even funding for startups. And in Singapore, this is big as a financial hub for the world. If you're interested in some of the other fields, such as medicine and biological services, we've mentioned pharmaceuticals, social services apply space technology for the greater good. Engineering and science that are not space related can do tech transfer. And then of course we need the core people who are working in science, technology, engineering, and maths. Let me just leave you with this bit of inspiration. I have had people ask me whether Singapore has landed on Mars already. The answer is not yet, but I just want you guys to think about this as your potential future. I am pretty comfortable saying that we will have human beings on Mars within the next few decades. So I hope that you guys can be part of this really exciting sector. A little bit more information here. If you want to know about working on experiments in space, you could email us, or you can look at any of the different social media platforms that we've got listed here. Thanks very much to you guys, and best wishes for the hackathon.